Physics, Coulomb's law. So, to describe Coulomb's law a little bit, we're going to go ahead and do an example. And this is a common experiment where you take a drop of oil and you drop it into basically an electric field, and basically the drop of oil will sit there and float. So in this experiment we have a drop of oil with a weight of 3 times 10 to the negative 14th newtons, and it is suspended and motionless between two plates separated by 1.5 centimeters. The plates are charged and have a potential difference of 500 volts. Find the charge on the drop of oil. So, as is always helpful with these problems, try and draw yourself a picture to see what's happening. So we have a plate on the bottom, and we have a positively charged plate on the top, and then we have a little drop of oil in the middle. And so that's what we've got happening. We have our knowns. We know the potential difference is 500 volts. We know the distance is going to be 0.015 meters, or 1.5 centimeters. The weight of the oil drop is 3 times 10 to the negative 14th newtons. And we are looking to find the Q sub E, which we don't know. So, with all problems, or most problems that involve forces, it's usually a good idea to draw a free body diagram. And we're just going to go ahead and draw a diagram of the oil drop. So in this diagram we have the little drop of oil in the center. We have the force, or the weight of gravity, pulling it down, and then we've got some sort of electric force that is pulling the drop up. And these two are in equilibrium, so the drop doesn't move around. It's just, you just have these two forces that are pulling in opposite directions. And then we went ahead and defined the up direction to be the positive y. So, for this, we know the net force on the oil drop is 0. And with that, we can go ahead and sum the forces that are in the y direction. And so when you sum the forces that are in the y, you end up with your F sub E minus W is equal to 0. And what this basically allows you to prove is that Fe is equal to W, meaning your electric force is equal to your weight. So, there's also a couple of other things. We need to substitute in a couple pieces for this equation, because we want to solve for exactly what is the charge on this particle. So we need to break down this this electrical force just a little bit. And so we know F sub E is equal to Q sub E times E. And we also know that E is equal to delta V over D. So we can go ahead and sub in those pieces of the equation. So for Fe, you know that it is going to be Q sub E times your E, which is actually just going to be delta V over D, and that's going to be equal to your weight. So, and then you can go ahead and solve this equation for Q sub E, and when you do that, you end up with Q sub E is equal to weight times distance divided by delta V. Then you can go ahead and plug in numbers and solve. And so you end up with Q sub E minus is equal to your weight, which is 3 times 10 to the negative 14th newtons, times distance, 0.015 meters, and then that is divided by your delta V of 500 volts. When you plug it in and multiply this stuff out, will end up with 9 times 10 to the negative 19th coulombs is equal to Q sub E.